So why do we need extreme astronomy? Everything in the atmosphere is pulling photons of various frequencies out of the air, whether it's small atmospheric molecules like oxygen, water vapor, particulates like dust and things like that. So, and here you see on the spectrum, visible light comes all the way through, not much absorption there. Most of the infrared bands, except for a couple notches here, like the thermal band, are blocked. Radio waves are pretty transparent. And the spectra we're worried about are right around in this region right here. So you can see water vapor here does most of the absorption. Carbon dioxide a little bit. Oxygen has a big notch frequency here, which a lot of the telescopes down there use. They avoid that frequency just to not have a big problem with it. But so what do you do to get around the problem? You observe somewhere where you don't have all that stuff in the way. So you could go into space with a satellite instrument or do balloon observations, which a lot of the instrumentation is first tested out on balloon flights. Or you can go to some places where you have very low atmospheric water vapor, like especially Antarctica. So Antarctica is pretty big. It's a little bigger than America. 900 miles flight from McMurdo here down to the South Pole. So the US has 3 bases. They do science at McMurdo, at the South Pole, and Palmer Station is mostly like oceanographic research and things like that, studying the animals around there. Okay, so you have very low precipitable water vapor. It's a lot better than even in the Atacama Desert in Chile. To make observations at long timescales in the Antarctic winter because it's dark 24 hours for several months. You can rotate around, targets aren't changing elevation. All you have to do is rotate your telescope and no field rotation as a result. And hey, it all started in 1956 when the first permanent base at McMurdo was set up. And Martin Pomerantz that same year was started to do cosmic ray research at McMurdo and saw the potential of Antarctica for a lot of astronomical uses. So in McMurdo, they do all the long duration balloon flights. There's something called the polar vortex in Antarctica. Whoops. Where there's a swirling wind that goes all the way around. So there have been some balloon flights that have made actually 3 full complete loops around there, been in the air for many days, but it's only a summer thing. All the flights come into McMurdo. ANSMET is the Antarctic Search for Meteorites. They're based in McMurdo. 80% or more of the meteorites found on Earth have all been found on the Antarctic ice and stranding zones. Okay, basically covered that. And this is a view of like the daytime sky when the sun is close to setting. You can see up here, there's actually stars visible once you cover the sun. Because you're at a 10,000 foot elevation, you're on top of 2 kilometers of ice and very cold. Okay, next. Okay, National Science Foundation funds all the research done by the U.S. Antarctic program. If there's no place on Earth better to do it, they'll do it there. They cover all your expenses. The only thing I was told you should bring for comfort is socks and underwear. I know several people who go there. So. And the seasons, they're not divided by the normal equinoxes and solstices. They just covers 4 months of summer and 8 months of winter. And that's it. And my friend Gil Jeffords here has done about 8 or 9 summer overs for New Jersey Institute of Technology. That's him on one of those LC-130 cargo planes flying in, cramped quarters. You have to go to the bathroom on the flight. There's a bucket in the back of the plane. That's it. No privacy. And there are a couple other slides I wanted to include in here, but for some reason they wouldn't play on PowerPoint. So this is him after arrival at the South Pole Station. He works out of McMurdo and South Pole, depending on where he's going. This is him out in the field. He services space weather monitoring stations that are located across the Antarctic plateau. So they fly him into each location, spends like a week there, and then flies into the next one with a small crew. He's not alone. So all the work in the summer has to be done quickly and efficiently. Everybody's battling for space and time, and the biggest problem is transportation. The weather is very variable. Flights can get canceled at any time. I know people have been stranded there for an extra month just trying to take the flight back home. Okay, this is the last flight out of McMurdo. Winter has officially been done. There's about 50 people on the base during the winter. I think that's been increasing over recent years. But what they start out with is a thing marathon. When everybody's gone and they're alone for 8 months, they watch every episode of the thing back to back. Great way to start a nice lonely season. So how do we get there? Everything comes through Christchurch, New Zealand. They're outfitted with everything they need there. You can bring 125 pounds of gear. There have been people who brought their own telescopes down and things like that. There's one gentleman who brought a C8 mount just to on his last season to do a nice 5-day time lapse of the sun going around in early December. Always bring a swimsuit, and you'll see why later. This is where you'll get outfitted. Everything is there provided for you. You have to make sure it fits. They got all the backpacks and everything for field equipment. Everything comes in on these C-130 planes, flying in from Christchurch. First through McMurdo. The airfield in McMurdo is actually on the pack ice called Pegasus Field. That's the only place in Antarctica you can land field planes. Everything else from there goes in on the planes that are ski equipped. Now, it costs a lot of fuel to fly everything in, so they started doing land drags across this red route. But unfortunately, with climate change, a lot of the ice pack is suffering severe cracking and things like that. So I don't know how long these land drags are going to be safe to do. But here they already arrived at South Pole Station. You can see the station here. This is what they call summer camp, where the overflow people who can't get housed in the station live. Okay. Now, as you get in closer, there's a lot of different research areas. You got the clean air sector. The higher elevations are off on this side of Antarctica, so all the katabatic winds flow this way. It's the gravity-driven winds from higher elevations that come down. And the clean air sector is here just to make sure nothing gets polluted, because they have an astronomical atmospheric observatory there too that measures all kinds of air quality components. And as you get a little closer in, they have the quiet circles where they do seismology research. Downwind sector is where all the airplanes fly in from, and the dark sector is going to be what we're concerned with in this talk. That's where all the astrophysics gets. And as we zoom a little in, you can see this hexagonal outline here. I don't know if anyone's heard of the Project Ice Cube. It's a 1 cubic kilometer of ice that they use as a neutrino detector. I discussed that in a previous talk, so that's not part of this one. Okay. And here's a little better view of the station. You've got the airstrip coming up here, all the flights come in here. You've got, this is where the original South Pole Station was. The new station is over here. And nothing really else needs to be. It's summer camp is listed on here, and so if people can go visit the South Pole if you have enough money as a tourist, except you're only allowed to go up here. They park their planes here. You've got a little camping area for glamping here, and you get to go to this little visitor center here, and that's it. You're not allowed in South Pole Station unless you have special invitation or reason to be there. And this is the camping area for visitors. It's the same type of, they call these tents Jamesways. That's what they use for the overflow people during the summer and the main station. And this is the, they have a little visitor center here with some information about what goes on at the South Pole, and that's pretty much it. That's what visitors get to see. So this is arriving in by plane. What you see, the new station, here's that atmospheric research observatory I mentioned earlier. And this is where all the dark sector stuff is. This is Ice Cube, this is where the South Pole Telescope is, and this is the Morris A. Pomerantz Observatory. And this is a better view of it from the other side. Now, what's going on here is these are the hot water drills for Ice Cube. They literally bore down 2 kilometers through the ice, and the lower kilometer is where they put all the detectors. They have like long strings of detectors for neutrino detection. Now, the South Pole Station was originally designed temporary, and what they did was on the old structures here, oops, sorry, that's where Old Pole was. I'll discuss some of the other later. They were trying to compact the snow to make a camping area on top of it, but the vehicles kept falling into the holes because it was totally structurally unsound underneath. So they decided to blow it up instead to end the problem. And then they let drifting snow fill it. But when you see what the old pole looked like, you can see why it was structurally unsound. There's all these old buildings here, and what they did as the snow drifted up higher, they built temporary walls and a new roof on top of that. They did that 3 times, so there's all these structurally unsound voids over it. So when 15 feet more of snow went on top of that, things started collapsing. So okay, so they replaced the old pole with this geodesic dome in 1975. It looks nice and modern, right? But inside, not so much. Same old type of buildings, just inside the dome, cramped quarters, and it only hold like 25 people for winter overs. So they decided to construct a new station between 2001 and 2007. They all have saunas. Every station since then, since the beginning, had saunas. You know, people are freezing, you need to warm them up fast. And they also had bars. You need some social activity down there. And this is the new pole station under construction. Once this was completely finished and operational, they tore down the old dome and everything in it. So that's no longer there. Now, 950 LC-130 flights to get all this stuff in. That's the most carbon-intensive building on the planet. So it's quite an attractive building. Let me go back to slide. As you can see, they built it on all these columns, and they gave the building kind of like an inverted wing shape. That's so the winds blowing through it would scour the snow out from under it and it wouldn't get buried. And all these columns have the ability to be jacked up another 20 feet, I think, if necessary. But they do a lot of grooming around there. You can see there's total void underneath the building. And this is actually the first station that had windows too, which is a big psychological advantage. And the winter overs get a big treat. Instead of a 7 by 10 room, they get an 8 by 10 room. Now, if you noticed the pictures of my friend Gil, he had his head shaved and beard cut short. I don't know if this applies to winter overs, but in the summer, you get 2 3-minute showers a week. You don't want to spend your time washing your hair. So, and they have a lot of facilities in there just to keep people comfortable. They have a 2-story gymnasium, greenhouse, and they do all kinds of fun things like a race around the world, which is, you know, only covers a mile, but you go through every time zone, so it's literally around the world. The 300 Club is an interesting rite of passage. As it says here, when it temps go to minus 100 outside, they cranked up the sauna to 200 degrees, and the hardy get all sweated up and they run outside, usually naked, around the ceremonial pole and back inside. Always wear your boots. And a face mask when appropriate, because I saw a blog about some guy who got outside, took 1 breath in, it was like, oh, almost froze the inside of his lungs. So yes, this is the one time, the first time they had the 300 Club meeting in daylight. Even though this is not officially sanctioned event, they did make patches up for it. And it's also a good, the ceremony pole, good spot for photography. Here they had the South Pole Beach Party in 2009. Yeah, it's a little chilly, -5 to -10 Fahrenheit, but yeah, it's hardy folk down there. Notice everyone's got the boots on, maybe except this poor fool over here. He took them off for the photo, but they're behind him. Okay. Okay. Now, this was an interesting thing I found accidentally. Yeah, one nice specially sanctioned event the National Science Foundation did was on the Ice Cube drill site. They had a special event and they basically built a big hot tub for New Year's. So it was in a construction zone, so everyone had to wear hard hats. There were a lot more pictures, everybody with bottles of champagne and whatnot, you know, but you gotta keep your crews happy. That's the bottom line. And every year they have to remark the geographical South Pole because it sits on a glacier and it drifts 10 meters every year. So one of my jobs, if I had gone down there, would have been to make the new markers. They have a little contest where everybody votes on a design and then the South Pole machinist has to fabricate it. So this is, I don't know what happened in 2013. This is 10 years worth of South Pole markers. And some of them are quite creative. A lot of etching involved. And that's a little mock-up of the South Pole telescope. Has etched glass. I think that's the one Bill was next to on his photograph. 2016. Just a while ago, I didn't update all the markers. Okay, Martin Pomerantz, who I mentioned earlier, was the first person to actually start doing astronomy down at the South Pole. And his first funded project was an optical solar telescope. He also set up a lot of work setting up a lot of the early CMB stuff. And this is the first funded astronomy in the South Pole. There's this is the little mirror which sends the image of the sun down into here, and this just rotates around and around. And they got 150 hours of continuous observation on this device. And Kara was run by the University of Chicago for some reason. I don't know why, but headed at your piece observatory, but they got to head everything up there. And this is what started it all. This is in New Jersey, not far from where I live in Homedale. And this horn is the one that first detected the cosmic microwave background radiation in the 1950s. I'm not going to delve too much into the history of it, but that's what they were looking for Bell Labs across the whole sky when they were trying to do microwave communication research first, and they found an emission from everywhere. And they couldn't figure out what it was. They thought it was bird crap in the horn and all kinds of things. They ruled out everything, but it was always this one thing at about like 3.5 degrees Kelvin that they were sensing. So what AT&T did later, this is like a miniature version of the horn. They set that up in 1987 at the South Pole as the first CMB experiment. And a lot of the members here are like Tony Stark especially and Mark Dragobin. They're really instrumental in a lot of the early CMB experiments, designing the instruments, etc. So this is the second CMB experiment. This is the first one that got taken over by CARA, the Center for Astrophysical Research in Antarctica. And the early experiments, they took a couple weeks to set it up. They had a couple weeks of observation during the summer, a couple weeks to tear it down, no observations in the winter. So they saw something, but no anisotropies or anything yet. So I think I basically covered everything that's on this. Para was supposed to last 10 years, but UFC still has a lot of control over what goes on there. I mean, there's a lot of associated institutions. So the first 4 projects were Whitefish, which I just showed you, the South Pole Infrared Explorer, that was a Spirex infrared telescope, ASTRO. I have an interesting story about that one later. And Cobra was actually had 2 different experiments in the same ground shield in succession. And Spirex did continuous observations, seeing if the South Pole would be a good place for infrared observations. And yeah, this is what it's most famous for, the uninterrupted view of comet Shoemaker-Levy impacting Jupiter. I think what most of the impacts. It had a little downtime during the last view, I think. And this is what the telescope looked like. It was a 30-centimeter telescope on top of a big platform.
John Briggs.
What's that?
Do you know John Briggs?
No.
He's the one who ran it
Oh,
from
right.
University of Chicago.
Oh, cool.
He retired. He's in Mexico now.
Nice, nice. These were the experiments that were part of Cobra. So Python is a CNV telescope. I think it only had, I think, like 4 or 8 pixels in it. And Viper went through a number of instrumentation additions, and the last one actually had a 16-pixel bolometer in it. So that's all they were looking at. Very, very low resolution, but they were able to make maps of the I don't know how to pronounce something Zojevich. It has to do with lensing of galaxy clusters by the cosmic background radiation. And okay, this is Astro. Actually, one of the members of the Kelt follow-up team, Tom Oberst, actually did a winter over on this instrument. Interesting instrument in that it was the first one where this is the roof of the building. The signal got sent through the roof into a room temperature cabin. And it's interesting, everything's off axis. There's nothing in the way. You have your secondary mirror here. And this is actually a folded representation of what the optical axis looks like. On this fold line, the rest of it is coming towards you and then down through the center tube. And this is what the telescope actually looked like. So everything was a little off center. Like this ball is on the far side of the center line that it rotates around. That's why you need the counterweight over here, etc. It's a better schematic of it. So the signal bounces off of here, up here, sideways, and then down this central tube here that it rotates around into the cabin. Now this is the instrument constructed, in place on this building. They have a little cover here out of canvas and aluminum tubing that they can flip over it when it's not in use. But this was the first telescope to operate throughout the whole winter in Antarctica.
What's room temperature?
About 70 degrees, yeah. They keep it warm. Actually, I don't know about that building. Where the South Pole telescope is and BICEP and all that, it's actual room temperature. This is an interesting instrument that was on it. Spiffy. It was a interferometer and spectrometer at the same time. So they're actually able to map the carbon monoxide flow that's swirling around the galactic center. It's also a spectrometer to tell where it was coming towards us or go away from us. I couldn't find the paper that showed the map of it all. I don't know what I did with it. It was 2017 when I first started researching this. So Astro was in its own building. Cobra and Spirex were both associated with the Morris A. Pomerantz Observatory. And after Spirex was decommissioned, in one summer, they had it removed and they mounted a new telescope, Daisy, in its place. I forget what Daisy stands for. It's something with the Antarctic interferometry. I had multiple, well, you'll see a picture of it soon. So they were looking for now anisotropies in the CMB, and they were finally starting to find them. And the more they refined it, and the more they refined it, everything seemed to be indicating that, what's it, omega sub 0, I think, equals 1, I think indicates a flat universe. And, okay, yeah, here they're, sorry, I didn't memorize all this stuff. This was just cut and paste from a paper. So, yeah, they're looking for how the CMB varied in temperature. That indicated various features, etc. And they're finding what they're looking for. So this is what DAISY actually looks like. Each one of these little instruments here is an actual separate telescope, and they could do polarimetry with it. I believe this whole thing could rotate in the base. The whole thing rotated in azimuth, and this whole thing swiveled back and forth. So this is Spirex being removed. And this is DAISY being installed. Now that telescope with counterweights and everything weighs 35,000 pounds. It's hard to tell on the photograph, but also they built a room underneath it, so it could also have a room temperature access to all the instrumentations from inside. There's a better picture of it. The next year they finally installed the ground shield, but they had already started doing some science with it. So they built a little walkway from inside the MAPO into the control room down there. And that was before they installed the detectors, and here are the detectors waiting for installation. Each one is a microwave refractor. These are actually polycarbonate lenses. DAISY went through several iterations. After its first science project was done, they took all the instruments out, put new instruments in it. It was a very viable, sturdy platform. And after that, the Keck array went into it. It was first named the South Pole Upgrade for DAISY, SPUD. But nobody wants to fund a potato, so when the Keck group took over funding of it, they renamed it the Keck array. And this is actually the instrument where this gentleman from Germany has spent 18 winter overs in the South Pole, mostly operating his telescope.
Say 18.
Yes, his nickname, the Iceman, because he has spent more time at the South Pole than anyone else. Forget his name all of a sudden. Anyway, so the Keck array actually used BICEP 2 telescopes in there, and the new one that just came online in 2019 is using the BICEP 3 telescopes, multiples. And everything depends on liquid helium. All the instrumentation runs at I think the highest one runs at like 4 degrees Kelvin. So they use pulse cooling on all the things. Some of them run at like milledegrees Kelvin. So they've got to get real cold in order for the instrumentation to operate. So this, I believe, is on top of the South Pole Telescope building. Here's the Morse Pomerantz Observatory with the shield from DAISY up top here. And back here is the South Pole Station. So liquid helium is the lifeblood. There was one winter they had to cut the experiments short a couple months before the end of winter because they ran out of liquid helium. And this is the South Pole Telescope in the background here, 10-meter radio telescope. And new experiments require a new building. Most of what I covered was in the Morse Pomerantz Observatory. And so this is where BICEP is located. That's a ground shield, that's not the telescope itself. And this is the 10-meter South Pole Telescope. I don't think it's been, full sheathing hasn't been applied yet. So that was pretty soon after installation. Here's another view. So this is BICEP. BICEP only used one telescope, where like the Keck array and everything used multiples of the same. Slightly different science. And South Pole Telescope again, a nice shot. Time check?
Pardon?
Another time check?
You're good.
Oh, okay. So, once again, they made sure that this could be operated like with all the maintenance being done in a nice controlled environment. So you notice this receiver cabin here, when the telescope is parked, you have access into it to service the cryostat from a nice room temperature environment. So they were originally going to build a full ground shield around this too, but they found out that this was all that was necessary. And this is inside the cryostat. This is actually the second detector that went in it. The South Pole Telescope is already on its third set of detectors, and we're researching the fourth set. So this one was when they added the polarization to it. So they had this angled filter here so that it wouldn't affect polarization. So the refrigeration is done through here. This whole thing is immersed in liquid helium. This is all the cryostat. And actually, the focal plane detector is here. It's actually a Gregorian telescope. So you come to focus in here, and then it gets reflected off the secondary up into here.
Unusual design. What's the wavelength that's captured? Roughly.
It captures in microwave.
Microwave.
Yeah, it simultaneously can observe in 3 different frequencies with the third generation. I think the second generation is only 2 different frequencies.
So that's a parabolic. So
Yes,
spherical.
this is parabolic. It's actually, I know the original one was actually made out of 7075 aluminum. Of all things. And this is the morning commute. You got to walk a kilometer each way to get to work from South Pole Station. And here it is. This is a view of the South Pole Telescope from South Pole Station. They have a line of flags there so you don't get lost. Because you can get disoriented out in the snow, staring up at the stars, etc. And I went through this a little faster than I thought. I thought I was going to run out of time. Might be 2 slides here, but here's what it is. One more. Or the thank you pages here. So National Science Foundation gets the biggest thank you because none of it would happen without them. Dean Karlstrom, he's the PI for, let's go back there. Right. Dean Karlstrom here, he's the principal investigator for the South Pole Telescope. Bartola Institute is where Martin A. Pomeranz came from. Yeah, I would have never found out about this if I didn't see this job listing. So, it was a good inspiration, and my late wife Sue for putting up with me researching all of this hours on end. And also, if you go to southpolestation.com, you can find out anything. You can get lost for a month on that website. Every photograph is clickable and take you to a new page, and you can see construction photos of every instrument there, links to a lot of the papers and everything that went on. And most importantly, thanks to the men, women, cooks and carpenters, researchers, administrators who all work at the South Pole doing the best science in the most inhospitable location and work. Remember, our tax dollars fund the best science in the world. And that is it. Thank you very much.
Thank you. Now I'm going to stop your share, and if you would move back into the lit up section there,
Okay.
so you can answer questions. I have one quick question for you.
Yes.
What's up with espresso quiet zone? Those 2 things seem not compatible.
That's the seismology research they do there.
Why espresso?
I have no idea. Everything's acronym driven.
Did you say seismology?
Doing experiments like Anita and Amanda, and everything needs a good acronym. In fact, the South Pole Telescope went through 3 rounds of funding before they approved it, because who wants to finance spin? Oh, yes.
What nations are involved with the U.S.?
Well, The United States operates South Pole Station, but the research there come from worldwide, mainly because of the instrumentation that's there. Concordia Station on Dome C is actually a higher elevation, better observing conditions. The European Union has been trying to get a radio telescope, ALMA style, built there for years and years and years, but they couldn't fund it. A lot of it is the logistics. You can't get the big airplanes flying in there and landing and things like that.
You
So,
mentioned elevation earlier in your talk.
right.
What's the highest elevation?
13,000 feet, Dome A. Yeah, it wasn't on any of the maps I had where I go back.
I thought you said it was.
Yeah, South Pole's at 10,000 feet. 13,000 is Dome A. There's several domes. Dome A, Dome C is Concordia Station, the European station. I think Marines have a base on one of the domes. Okay, good question.
How variable is the weather in the summertime?
In the summertime, well, you can get, depends where you are. Like people who do all the field research and stuff and ANSMET, you can have storms that blow in for a couple days and you're confined to your tent. And you know, you have to wait for the weather to clear before they can do anything. But it's pretty variable.
Why do people have to walk a kilometer to go to work? Why is everything so spread out?
Well, the dark sector, they have to have it separated from everything else to cut down radio interference, light pollution, heat signatures from the other buildings, and things like that. But yeah,
Patty, you're muted. Why are you not coming through? Say something.
Who?
Me?
Oh, okay. I wanted to make sure I could hear people because you were, I saw your mouth moving, but I didn't hear any sound.
I'm just here saying wow a lot.
Okay.
I have some questions. Should I wait till the questions in the room are done?
Okay, hang on. We can look at your questions in chat if you want.
I haven't put them there yet.
Oh, okay. Somebody did. All right. Well, what are your questions, Alan?
First of all, ski-mounted balloon launch. I might have missed your explanation of that, but what is that again? Ski-mounted?
They have big, large buildings that they launch from. The buildings are actually on skis. They're the largest movable structures on the planet, where they're kind of like hangars. They park them at McMurdo in the winter, and then they tow them out to the launch site during the summer when they start launching balloons.
Cool. Great.
I covered that in a previous talk on McMurdo astronomy, unfortunately. So this is actually part 3 of my astronomy for Antarctica series.
Well, it was a great presentation. Absolutely fascinating. I should know this, but I don't. Are the seasons equal in length?
No. When they can fly in and out, what they call the summer season is only about 4 months long.
Got it. And does that change on a larger cycle because of Earth wobble or anything? Do you know?
No.
Okay. What's in the fuel bladders? Like, how do they heat that place? And have you ever run out of fuel?
Well, fuel is a big problem. That's what it affects their generation capacity. There's a limit to how much science they can do because everything requires power. So they're actually running the generators at 110% capacity.
Wow. What kind of fuel are they using? And does the current conditions in the world affect that directly?
They use jet fuel because it's nice and clean burning. Actually, a lot of heavy equipment burns diesel, but you know, the construction equipment. But
I have two other ones that aren't quite. They're not astronomy related. How often are there like individual personal cold weather emergencies where somebody's got to get thrown into the sauna or they're going to freeze? Does that ever happen?
well, the year after I was going to apply, that winter, they had an emergency where they had to fly some woman out in the middle of winter. And they don't like to do that because the fuel hoses don't bend. They have to refuel the planes and all that kind of stuff. So I forget the instance. I think she had some breast cancer that was in remission.
Yeah, I remember that.
Started getting very aggressive. They had no way to treat her. They only had one doctor on site.
She was a doctor.
And one last one. Are there a lot of romances there, or do they have strict rules against that?
Actually, there's something they call winter wives there that's not spoken about too often. Where, yeah, some of the people get a little chummy and share rooms and stuff like that, but,
Just FYI, she was the doctor.
yeah.
That was the problem.
Oh,
Like
yeah.
what goes on at the South Pole stays at the South Pole.
Yes.
Thanks again.
Actually, I forgot to mention the story about Astro. When they started looking for funding for the South Pole Telescope, they insisted that they have 2 staff scientists operating it because of an incident that happened on Astro, which I found this in like one paragraph in one paper and nowhere else. What happened was one of the winter rovers, the scientist operating Astro changed the passwords and wouldn't let the people on US mainland into the computer system and started running his own observing program. I have never found out who it was. A lot of people I've talked to know the story, but they don't know the details. I just want to know if he did good science.
Beside watching The Thing, did you ever see the Big Bang sitcom where they stayed at the South Pole and they wanted to let the guy stay outside and freeze to death because he was a pain in the ass?
Yes, I have, but that was the North Pole.
Oh, I thought it was the South Pole. Okay.
They wouldn't have been in their own little cabin then. They would have been at the station.
Jim, in that 300 club, does anybody wear their masks more strategically?
Well, some people wear their suits.
Wait, what was that? What was that last word, Michael? Wear their masks, what?
Strategically.
Ah, got it. Okay, never mind.
Gives a whole new meaning to South Pole.
Oh, once you hit the cold, I don't think it would be cold.
Worse than a cold shower.
Yeah, quite.
Great lecture, Jim. Thank you very much.
Genitalia, I will mention that. That is dangerous.
All right, any more questions online? We have some things in the chat. They may be complaints.
Sure. Why can't you get this talk going? There you go. Someone asked about espresso.
Oh, okay.
There's an answer there.
Oh, and the bar joke, we don't need that. Okay. All right, well, thanks an awful lot, Jim, for
Thank you very much. Great.
Thank you so much.
Okay, folks, we're gonna shut it down. Thanks for logging in.
Mike, have a great evening.
Thank you, Michael. See you next month.
Michael. Thanks for your.
Bye-bye.
Bye, friends.
Bye all. Bye.
Don't worry about this.